All right, the local time is 11:30 p.m. This is IETF 101 on July 27th, 2001, and this is the Global Routing Operations Working Group session. Chris, is the slide sharing working?
I have actually no idea how to get the PDF in there, so I can just share the slides, and the people who want to do their own sharing can do their own sharing. Unless this works. Didn't work, huh? Wait, that's the wrong. That happened.
Right now I'm in Amsterdam, and here it is 11:30.
Just clicking the Ask to Share Slides button should have brought up the list of all the things that are in Data Tracker, and that you can then just share from that, I thought, but I might be wrong.
So if I click that button, it shows up as no slides available, even though we uploaded stuff into the Data Tracker a few hours ago.
I think I even published the wrong set of slides. I have no idea where they went, so we'll try this whole again. In the meantime, we'll just share the slides the same way. Oh, good Lord, where'd they go?
You are starting the screen share, right?
Yes.
Okay. Let's try again. Welcome to IETF 111. This is different than 101. Next slide, please. This is the famous note well. Please queue up if you have questions for presenters, and review this information in detail at a later moment. Next slide, please. There are various materials related to IETF 111 and the GROW session. Review this as needed. The blue sheets will be filled in automatically because of the registration/data tracker system, but we will need a minute taker. The minutes are on something called codimd.ietf.org. It's kind of like Etherpad as we had last time. Are there any volunteers to take the minutes? Then I will volunteer myself. A Jabber scribe. Is there anybody who wants to monitor the chat room?
you don't need to have a JavaScript since it's integrated with MediaCo.
Chris, can we move on to the agenda?
Certainly.
So we're going to start off with an update from Thomas on BMP Yang and what they accomplished at the hackathon. Then there is Rai Han, I don't know if I'm pronouncing this correctly, who will share some ideas on the exchange of PGP looking glass mechanisms. And then last but second to last, Sriram with an analysis on BGP community as they observed them in the default free zone, and a agenda item that is on the text file but not on this slide is Paolo Lucenti, who will give an update on BMP TLV. So we should not forget that after Sriram, Paolo has an update as well. And that's it for today. I would like to hand over microphone and video and screen sharing to Thomas Graff. I guess for you too, it's the middle of the night, Thomas.
Yes, it is. So, hello everybody, can you hear me, hear and see me, and also the slide deck?
We can hear and see you and the slide deck perfectly fine. Thank you.
Okay, excellent. So, yeah, hello everybody. Give you a small update on what we did last week in the BMP hackathon. So again, we were focusing on performance tests around BMP, basically on the what is the impact on BMP loggrip, the additional TLVs, also around path marking, especially when the BMP session is stable, unstable, and also when the BGP peers are either in stable condition or being re-established entirely. So we want to see basically what is the impact on the BGP propagation delay, so whether BMP is enabled or not, or also if under congestion state that BMP route monitoring is always being able to export the RIP state properly or not. So that's basically the software we used. Here at the end, a small blog post if you want to establish your own lab setup. Here, just the lab overview. So on the left-hand side, the ingestion from XRBGP, where we ingested 1 million VPN-v4.
Thomas.
Yep.
So sorry for interrupting you, but
Sure.
I do not see the slides advancing on the shared screen. Are you maybe looking at the presentation mode but sharing the PowerPoint application?
Then let me try another way around. Can you see now the slide deck advancing?
You may have to share your screen again.
Okay, then let me try that. So is this better?
And can you press? Oh, yeah, perfect. Thank you so much.
Good. Okay. So that,
I will cease my interruption. Would you mind going back one slide?
Yeah, sure. Can you see the back and forth this time?
Yes.
Okay, good. So that's the hackathon plan, which I just mentioned. The software used here, the topology. So on the left-hand side, XRBGP ingesting the routes, 1 million as fast as possible. a Juniper route reflector, which has BMP adjacency rip out configured. The route reflector in between, where we did the manipulation, the PE flaps, the BMP flaps, and the PE router basically importing all the routes, and we are comparing the adjacency rip out versus the adjacency rip in, where we measure the propagation delay throughout the route reflector in between when BMP is enabled or not. The test automation is progressing. This time we were also able to measure most of the things through a young push. We have in the meantime 4 different operating systems running. Next step will be to scale higher in the topology. Also use the Cisco and Juniper routers as route reflectors and see there what the difference are. And also we are looking forward on improved timestamping on Huawei VRP. Speaking of timestamping, this is the difference between among the vendors. Cisco iOS 6E also now have timestamps in milliseconds compared to last time. This is the Yang models we are used to actually measure the BGP and the CPU impact, and the memory impact. And this is one test result here. So basically, we are measuring the latency when either under stable condition on the left side, when BGP is in stable condition, on the right side when we are flapping the BGP peers. And you can see the difference when in the middle the route reflector BMP is enabled or not, and it shows the slight overhead we have on the propagation delay when BMP is enabled. This is the difference between also on the propagation delay when BMP either is turned on, off, or the BMP is flapping. Here, the CPU impact when the BGP, all the BGP peers on the route reflector is flapping in terms of CPU utilization and memory utilization. Here, the Juniper router, which is basically in this case just in transit, measuring BMP adjacency rip out, and depending on the central route reflector, the Huawei router, if BMP turned off or on, we don't see any difference in here. So basically, the BMP on the route reflector doesn't change or doesn't have any negative impact on the entire routing topology. Here, the same view on the PE router on the Cisco side, also more or less showing a very similar picture. So I would say the test automation helped a lot. We were this time not progressing that fast as we wanted. Had some instability issues when we tried to scale higher towards 4 million routes. Need to optimize a bit our test bed, and yet again, we are missing the beers and the cocktails. And thanks for Alex, Pierre, Paolo, Marco, and Matthias also for the help. That's all from my side.
Thank you so much for this update. I really appreciate that you and the team are taking the time and care to thoroughly analyze how these protocols interact with real-world equipment and numbers that resemble the size of the internet.
Sure. Thanks a lot.
Are there any questions for Thomas? I see Thomas raised his hand. I can only remove Thomas Magin from the queue. That's weird. Can you click it, Chris?
Remove him too. He should be able to just speak. I think just turn on his audio and maybe video if he wants. Guess I should do that.
Oh, yeah.
Possibly you also, Thomas, have to go tell your browser to accept the permissions to use the things. Oh. No permission for audio, he says.
Okay.
He's getting lots
Can
of
you
good
type your question? I don't know if the two Thomases are familiar with each other, but Thomas Magin is the primary author of ExaBGP and is offering any assistance
okay.
The BMP testbed people may need.
Ah, interesting. Didn't know that.
So next hackathon, you should invite Mr. Magin to help with the ExaBGP work.
That's a good idea.
Thank you for the offer. Any other questions? All right. With no questions, I propose no further questions. I propose that we move to the next item in our agenda.
Cool.
Thomas, thank you for your time.
Thanks a lot.
Raihan Yaufurali,
Hi,
please
can you
teach
all
me how
hear
to
me?
pronounce. Yes, I can hear you.
Yeah, I'm Raihan Jofurali. I'm in Zurich, Switzerland. It's also 11:48 p.m. over here. Let me figure out how to present the slides. It says no slides available in the slide deck to share.
Yeah.
Yeah.
Do you have the PDF that you can maybe share as your screen?
I sent the PDF to the Grow chairs. Would it be possible to present that?
Yeah, I'll just do that
Sure, thanks.
since I have it up. There you go.
Thank you. So hi there, I'm Raihan Jofurali. I'm going to present about basically an idea that I had to allow the sharing of Looking Glass addresses through BGP. Just as a disclaimer up front, like I don't really mind in which way this is going to be implemented. I just wanted to bring the idea up. So the current implementation in the draft here and in the document which I put on the data tracker is just like one way it could be done. And I'm really open to any feedback that you have on how to actually do this. So next slide, please. So the problem that I wanted to solve with this mechanism is that when you're turning up a new BGP session, how do you know that the peers that you're announcing the routes to have actually accepted it? How do you know there's no misconfiguration? Maybe there's a filter that has a typo in it and the routes that you want to announce are being dropped. Like in the mechanism that we have now, you would just manually have to go and check that. And when you're doing things like anycast, when you're announcing the same prefix in multiple places, if you just ping the address, you won't know, is it going to the right place? So what if you could programmatically check that the new point of presence you're turning up has come up online and healthy? Next slide, please. So the current way that I believe people check for route acceptance is through Looking Glasses. So many providers have a web interface where you can go and type in like an AS number or IP prefix and select which router you want to query, and it'll print out some kind of dump of the routes that router is seeing. So the human operator can then go to that web page, type in some prefixes and check that, hey, is this Looking Glass showing a view from the peer that I expect the peer to see. And this process is very manual, it's one-off. You can't really programmatically probe and see like 1 month in the future, is something changed? Is it still working correctly? Next slide, please. So the idea that I had was to add a new administrative message by using this multi-protocol reachable and multi-protocol unreachable path attribute in the BGP update message. There was a bunch of discussion in the mailing list about like how to do this. When I first emailed the mailing list, I think someone brought up the idea of using the address family, and that's kind of how I went down this path. There was also some discussion of the BGP operational message, which I thought was really cool as well, but I didn't really see any implementation of that, which is why I kind of went down this path here. So in this approach, it would use the payload in the multi-protocol path attribute to put like a type length value in there, and one of these TLVs can be containing the autonomous system number and a looking glass for that autonomous system number. So this approach lets you send it to direct peers as well as forward looking glass URLs for peers of peers. For example, if you want to see what the looking glass address for a tier 1 ISP is when you're a Leaf AS. Next slide, please. So using this path attribute would require the peer to send a capability in the open message to say that this new address family is supported. Direct peers can send their looking glass themselves. And one way I thought that the propagation could work would be that if an intermediate AS forwards a route to one of its other peers, it would know whether that other peer has a looking glass, and it could then forward that looking glass address to the peer which sent it the route. Next slide, please. So just as an example, say we have a Leaf AS that connects to some transit AS, which has then like some tier 1 ISPs above it. So when the Leaf AS connects to the transit AS can say, hey, this is my looking glass, and then the Leaf AS can check for acceptance in the transit to see whether the route went to that first hop. And then when the transit AS forwards the routes to its upstreams, like AS 1, 2, and 3 here, the transit AS could then forward on the looking glass addresses back down to the Leaf AS, and the Leaf AS can then probe those upstreams to see whether the route has been accepted there, or if there's any prefix filtering issues or RPKI issues or other issues with that. And in a similar way, that could be done in a Internet Exchange route reflector on the right. Next slide, please. So there are a bunch of open issues with this kind of proposal. One of which is that the RFC 8522, which defines the looking glass interface, which I kind of piggybacked upon, doesn't actually specify any machine readable data in there. It just outputs free-form text from whatever the looking glass decides to return. Some people mentioned that we could use a top-level domain of .bgp and then just put all the looking glasses in there, and that would be how you would discover them. And it's unclear, there was some discussion in the mailing list as well as to whether the looking glass would show you the full rib and what information you'd be able to glean from that. Next slide, please. So that was all I prepared in the slides. I'd like to open up the floor to any discussion if we have a few minutes.
We have some time. I saw Jared March first in the queue. Jared, go ahead.
Yeah, I think we've been kind of hunting around this in the industry for a number of years. There's been this concept of like Twitter for BGP, or a way to send messages and like different things. And I specifically have an operational problem around discovering not if it's propagated far, but I want to understand if if the provider or the adjacent device has actually accepted the prefix. Because I think that there's a lot of things where we're, especially, you mentioned Anycast in your use case. An Anycast prefix, when you look at it externally, it's just going to have an AS path. And that's not going to tell you it was accepted by the partner device that you may have a BGP session with. And so I think that there's likely there's work that should be done here. I'm not sure if it would be here or in IDR for the messaging component, or a way to basically key or get a copy of the data from a partner device via BMP or something. But you mentioned things like RPKI invalids, and I think that I'm already hearing like Jeff Haas in the back of my brain talking about the challenges in trying to understand why the partner device has rejected a route as well, and the additional code complexity that's going to put into the BGP implementation to understand why the policy engine of the partner device. But I really think that something like this needs to be done. Oh, and I prompted Jeff to join the queue, so I'm going to drop out now. But yeah, I think this is interesting work, and I think it's potentially valuable work.
Just to add to that last note there, I think there's still value, even if the code doesn't programmatically know what's wrong, just to be able to detect and flag an alert saying there is something which is abnormal would still add value in itself.
Next up was Ben Madison.
Middle of the night here as well. Yeah, so I largely echo what Jared said. I think it's a genuine problem that you're trying to solve. I think that going down the trying to auto-discover the location of looking glasses is a fundamentally flawed approach. And the reason for that is the problem that Jared mentioned isn't just any cast, it's any pair of ASs where there are multiple adjacencies. Because typically people's looking glass interfaces, certainly true for us, are not going to give you access to go and look at the ribs of every single router in the network. Typically it's one per POP or one per region or something like that. And trying to glean from those interfaces whether or not a specific prefix is showing up on a specific adjacency requires all sorts of additional knowledge of your neighbor, like what's their IGP topology look like, what are their loopback addresses, et cetera, et cetera, et cetera. So I just don't think that's ever. I think even if you solved the machine readability problem, we had a standard interface and we had a neat way of discovering all of this sort of thing, I just don't think you get the information you need that way. And I think Jared's right. This needs to be some sort of a echo mechanism where a speaker can respond to a update with, "Yup, I ate that," or "No, I threw that on the floor."
Cool. That's really helpful to know that and kind of steer where this could go.
An additional challenge here may even be that even if the adjacent router has accepted the prefix, we don't know if it will propagate beyond that, because local policy may attach no advertise, or there may be other paths. Next up in the queue is Jeffrey Haas.
So I guess two sets of comments. The first one for discovery, certainly posting stuff into BGP, that's what the admin style messages were useful for. And the lack of implementation shouldn't bother you too much. Basically by asking for something like a do AFI SAFI, you're asking for people to change their code to do this stuff anyway. This is sort of a funny thing to fit into a route, and I think I would echo some of the other comments that making this thing transitive is sort of a odd behavior. I could also observe that you could just literally stick this information into a DNS PTR record for the IP address that you're peering with the service provider. So there's ways for us to sort of publish this in a public format, and we've had discussions among people in this group about we're sort of in need of general internet service provider registries of various sorts. This is just another flavor of that. So this might be worth solving in a directory style sense. Something gross, absolutely within Charter to do is just say, here's a way for us to actually get together and start gathering this stuff in a common place, common taxonomy, common data model, all good stuff. The second point, just sort of talking back to Jared, we had a personal conversation about what a feature, that's sort of an echo service would look like. And a true echo service of parroting back exactly what you send is sort of tricky. You're effectively turning the full loopback mode, especially if it's on demand, into an actual another BGP peer. So that's sort of something that would impact your scaling. But that's actually not the thing that I'm terribly concerned about. We know sort of what that would look like. What I think is probably a more interesting discussion point for people in this group is to decide what the privacy implications of this would be from a service provider perspective. And privacy means a little bit something weird here. If I'm some service provider that just ate your routes and I've done things to them, and those things may or may not impact what I'm going to do as I advertise those within my network and potentially to further networks, I may not want to show you that. So there may be a good motivation to say, yes, I have accepted your route, and it is indeed eligible for route selection. And if it stops there, basically what the echo service would look like is getting back a list of here's the prefixes that I've accepted for given AFI-SAFI, potentially with ad paths. And that is a fully tractable feature. Past that point, I think the privacy considerations kick in, and the operators in this group are going to be strongly opinionated. It'll be interesting to hear what they have to say about it. That's it. Thank you.
Thank you, Jeff. Thomas Mangin.
Hi. I'm going to be sorry because I'm going to sound very, very bad. The road to hell is paved with good intention. And I've seen enough RFC to see that one is, again, a good idea, which I think is going to get little traction from vendors or not going to do things right. Also, I must admit, I have, as a developer, kind of an aversion to use AFI-SAFI to carry non-AFI-SAFI information. And I think we are blurring the line of what it is and then what is next, what is going to carry in BGP. And I already found BGP to be the kitchen sink of everything, and it's making it a nightmare to maintain and to develop. So I'm not sure what you want to do, I think, is trying to solve a genuine operational issue. And I can genuinely see you must have put a lot of effort in that document to try to get done. And I'm sure that job as well knows how painful it can be to try to get draft through. I do not believe that I personally will support such documents whilst I can see that you have a need and you're trying to help. So I'm very sorry to be another voice not supporting the idea. Very sorry for that.
Sure, no worries. I mean, I'm also happy to not pollute the namespace of AFIs and SAFIs with this other random thing, which is not addressed. Like, even just for me to understand what this was and how to fit it in, like, seemed pretty nasty to stuff it in there. I think like the operational message would be great, and maybe I can like look into that further. I
wish you good luck. Effectively, if we can find a solution, it would be nice.
Rudiger Volk.
Am I being heard? Okay. Kind of, I'm not into discussing how to present the information. What I'm interested in first is what function are we actually looking for, and what are functions that are reasonable to look for, and what functions may actually kind of disturb. And there, I think actually providing feedback about the probably few rejects that someone has in his ingress policy is really of interest. If someone actually leaks the whole table, of course, the flood of messages also are kind of useful. So that's not really a problem. In the GROW group and in other discussions, I have a couple of times told that I think it would be a good thing for operators, when they define their ingress policies, to optionally mark the reason why a certain rejections happens. and kind of in the function that is of interest, obviously that would work nicely together. And kind of, I would even think that without global standardization of all possible causes of why someone doesn't want a route, exchanging with your neighbor, if you are seeing codes for rejections, the table that is used in the particular case probably is not completely unfeasible. Like actually the conventions used on your coding in communities is something that is not yet globally standardized to all the details. Again, I have not been thinking that much about how to code the damned stuff, but I think it would be a good thing to figure out how we could address this functionality, and kind of going for really going for looking glasses and looking into large tables for tracking certain routes. Looks like something that is kind of less attractive. So
yeah,
thanks.
I completely agree that like the thing you propose to only get feedback on the ones which were rejected, even from direct peer, would be really useful in the case where there's something clearly wrong with what you're announcing. And I think that could be the future direction of where to bring this.
And then we'll switch to Jared March, last in line.
Yeah, so I was just going to comment back on a little bit towards what Jeff Haas said earlier, which is I think there's a lot of opportunity here to figure out what we, ways that we can solve this that are going to be helpful for operators. I think there's a lot of potential here for scope and feature creep as well, where people are going to say, I want this or I want that. I think that the simpler that we would keep a solution in this space, the better. I think distributing, locations for looking glasses and stuff, I think it's going to be interesting, but that's going to be much more useful to do through, posting it on a web page and just people keeping an up-to-date list. I think for this, there's probably the most interesting pieces of work here are around what the operator requirements are for the space and focusing on whatever that minimal viable set of requirements are, and then determining what, if any, protocol changes or additions would need to be done, and liaise with IDR to determine what those are and how to get those implemented. Because as Jeff mentioned, understanding whether or not a route is eligible for path selection is probably as far as I think we could probably get. And also remember, there's a lot of really complex networking things that people do these days, and so that use the internet protocols but aren't the internet. So people run lots of things like VRFs and other interesting AFI-SAFIs internally, and trying to go and implement something that works across those as well, or to talk about that solution space, will get incredibly complex very quickly if we try to cover all of that. So I think, focusing on what an operator requirement would be, I think, like that's my concern. I'd be happy to work with you to at least talk about what the operational requirements I have in my environment, which I think is relatively modest, but we'd have to see what other things, and I'd be willing to work with you to get something to present to the working group on that.
Cool, thanks.
All right. Raihan, thank you so much for coming to this working group. I think this is your first presentation in the GROW working group,
It is. Thank you.
Thank you. I hope it was enjoyable. It appears there's many avenues to follow up on this work. I think part of the working group enjoys talking about very specific problem statements. So for instance, how to find a looking glass URI is a different problem than is my route accepted or not. And of course there's overlap to some degree. But the first can perhaps maybe be exchanged through an operational message or via DNS or peering DB or the RPKI or and then the second question is the route accepted or not has certainly some challenges. So I look forward to more of your work and ideas in this problem space, and please feel free to work with people like Jared Mauch or the Grow chairs, or we can introduce you to anybody you want.
Sure, thanks so much for the support.
Thank you for dropping by. Then next up, we have Mr. Sriram.
You can hear me all right, Job?
I can hear you, and I see the screen share is being started, but it's not yet shared.
Do you see anything yet?
Not yet.
So
Maybe Christopher can share.
Oh, I asked for permission to share screen again. Let's try one more time. And what do I do after that? I request permission. And
Which you have.
I have permission. So I go to my the PDF, right?
I don't think either Joe or I understand how to make the share slides from the pre-shared PDF thing work. So I can share a Chrome tab that has your content in it if you like, or you can continue.
Yeah, go ahead. Please share my slide.
Oh, sorry.
I have to stop share screen share. I did that.
Yep, no problem.
And I'll make a slide request to.
Here we go. I can see the first slide.
Okay, good. And I asked to share slides. Chris, if you can allow that, I can then control the slides, it seems. All right, so this is, we only have like 17 minutes for the next two talks, so I'll try to be as quick as possible. So this work is related to analysis of propagation of regular extended large communities. This is joint work with Lilia Hanachi. Several people have offered us comments on an earlier version of the slides. Thanks to them. Next slide. Okay, so RC for regular community, EC for extended community, LC for large community. Next slide. So the motivation for this study, there are drafts that are in progress in the IETF. The applications there require EC, LC transitivity, at least over a few hops. The GROW route leaks detection mitigation draft is an example. So the question is, can they get the transitivity of LC, EC that they need? There was an extensive discussion on IDR GROW list about that. So we decided to focus on studying and measuring the propagation of EC and LC to help that discussion. Next slide. So there's been prior work on regular communities. We focus on extended and large communities. Next slide. So some basics about the measurements. We make use of route views and RIPRIS data. We consider only unique prefix AS path and the community combinations. And the technique used by here in this study is similar to what was used in the Stribelt study. So you look at the AS number in the community, match that AS number with the same thing in the path. And then from there to the left, the update is assumed to propagate. In this example, from 3491, the update propagates 2 hops to the leftmost or most recent AS. So it's a 2-hop propagation in this example. The community could have started much earlier than 3491. So in that sense, it is a conservative estimate of the number of hops of propagation. There are other reasons that are listed here why this number of hops estimate could be a conservative or low estimate. We can move on to the next slide. So this is an example of a real-world update with regular community as well as large community. So one thing I might like to highlight here is that we see three tier 1 ASS that are we see them transitively propagating both regular community and large community. And those are level 3, PCCW global, and 2914 NTT. Next slide, please. So we look at the 2-octet and 4-octet AS in the extended community. So here is the structure of the extended community. We look at the global administrator. We convert the hex representation into decimal and compare that with the AS number in the path. Next slide, please. So this is an example of an update with EC. The extended community is represented as unknown attribute in the update. So we look at that number 16 in the middle is the ID for IANA assigned ID for the extended community. So, and the global administrator EA2B, the hex notation is converted into 59947 decimal. And in this case, from there, it propagates 2 hops to the leftmost AS. So 2-hop propagation. Next slide, please. So these are some notes about regular communities. Most of us are familiar with this. I just want to point out that the black hole, no export, those kinds of communities, it is a good thing. They are not seen in the measurements. They should not propagate. They are not seen in the measurements. The black hole community can be represented, encoded in 2 ways. The AS number of the RTBH remote triggered black hole provider, followed by 666, or the WKC 65535 666. Next slide, please. So there's a notion of, for the black hole community, AS distance to the RTBH service provider, and also the propagation. So if we look at this example, 3356 is the RTBH provider, and the originating AS 6147 adds the community. It propagates 2 hops to 3356, the RTBH provider. So 2 hops is the AS distance in this case, and the propagation is, in this case, the community propagates all the way across from right to left in the AS path. So the number of hops is 3. Next slide, please. And then we take care of some additional things related to how we take care of like the transitivity counts for the ASS, and some special consideration needs to be given for black hole community, and that's what we do. We explain in this slide. We can skip this slide. Next slide. So this is where the results slides start. We have it. We are looking at RIPRIS, July 15th. the full day, 24 hours. Total number of updates, 52 million. Out of that, we extract the unique number of prefix path and various types of communities. We also provide data analysis on the number of transitive ECs, number of transitive 2-octet, transitive 4-octet, and a variety of statistics related to the black hole community involving the 666. So one thing to note here is there is also 00, which is the so-called internet community. We do see like about 18,000 of them. Internet community means it can propagate to anywhere in the internet. All right, next slide. So this is large community propagation distribution. We see it propagates all the way up to 10 hops. Fairly reasonably high numbers at 1 hop, 2 hop, 3 hop propagation. 0 hop simply means that the leftmost AS happens to be the peer of the collector. So there's community, and the community AS in the community matches the leftmost AS in the path. So it didn't hop, it didn't propagate. Otherwise, we see 1 hop, 2 hop, 3 hops, fairly reasonably good numbers for the large community. Next slide, please. Extended community, similar. We see reasonably good numbers for 2, 3, 4 hops. There's a large bump at 0 because some peers tend to send a large number of routes with EC. Don't know why. So all these 400, 5,000 routes at 0, they all come from one single AS somewhere in Singapore. But what this slide does tell us is that there is propagation across like up to 4, 5, 6 hops. Right. Next slide, please. So here we are showing the frequency distribution as a function of the extended community type on the x-axis. The good thing to note here is that only transitive ECs are seen to propagate. Non-transitive ECs are not seen. That's a good thing. Next slide. So here, one thing to point out here is we are looking at the ASS that propagate, and about 3,800 ASS in all propagate either RC, LC, or EC. And if you ask the question, what percentage of transit ASS propagate these, 32% is the answer. And then 22% major ISPs propagate RC, and only a small number, 3 or 4, propagate LC. That may not be bad news because the applications for LC and DC may be such that they require the LC to propagate only to the tier 2 transit provider or maybe the tier 1 transit provider, and then after that it does not propagate anymore, and that's why we don't see tier 1 major ISPs propagating LC EC, possibly. So Jeff Haas commented to me in an email earlier that you need to look at the application, some kind of a catalog of applications and what kind of transitivity they require, and then do the measurements against the knowledge, a knowledge base of applications for these. And we can try to attempt to do that. Next slide. So this is these results are similar to what are in this Stribelt paper. Regular communities propagate also quite substantially over many hops. Next slide. 2 more slides. So for the black hole community, the brown curve shows the number of hops to the RTBH provider. The blue curve shows the number of hops end to end that the black hole community propagates. The average of the number of hops to RTBH provider is about 3. The average of the number of hops to the for the total propagation end to end is about 5. So there's a difference of 2. So it should not propagate beyond the RTBH, but it seems to propagate or continue propagating. Next slide, please. Here we are showing the top 25 ASs that propagate any of these communities. So it's a ranking of ASs based on how many RC, LC, or EC they propagate. And in the RC clade case, more than half of the top 25 are tier 1 ASs. Right, continue, next slide. So in terms of conclusions, so we see that there is evidence of LC and DC propagation. There was a question on IDR GROW list, whether they propagate at all if the providers drop them on site. So that's not quite the case. Considering this, questions for the working group are, what are working group thoughts on support for use of LCEC in applications, drafts where transitivity is needed? Would the working group make any new recommendations for operators concerning handling of LCEC? Yeah, thank you. I can stop there and take questions if there is time.
There's a little bit of time. Jeffrey Haas.
We don't hear you yet, Jeff.
Can you hear me now?
Yeah, good.
The Joyce Meet echo. So what your slides have proven is that we're actually seeing stuff being passed around in transitive fashion. So that's partially what you're trying to answer for your application. I think the thing that is not necessarily a clear conclusion is that service providers are willing to pass them around in a way that allows you to safely use them in a transitive fashion for any given application. That's it.
Yeah, okay. So, yeah, so I mean, your comment to me in the email, I think it's along those lines. Maybe we can have a list of, a compilation of applications that use ECLC and then do the measurements against those, so that will give us an additional better picture as well.
Rudiger?
Hi.
Hi.
In some discussions, I raised the consideration of what hygiene should be applied to what you are announcing. Typically, people are concerned about the hygiene on what they accept, but kind of in any peering relation, you as the sender of information are responsible for what you are sending. And if you are sending stuff unfiltered, well, okay, spreading unknown viruses because you are not applying a mask, where you do not know what you're doing, quite obviously is something that does not match with the concept of being responsible for what you are doing. So I think that a lot of the propagation that you are seeing actually should not be happening, and kind of propagating stuff where there is not an agreed understanding of the security implications is something that should be avoided, though kind of this today, nobody is applying really that much of hygiene. But actually it should be considered that way. Thanks.
Yeah, thank you, Rudiger.
Thanks, Shriram. I think we should try and get Paolo in if we can. We're going to be super tight.
Thank you, Sriram. Paulo, are you locked and loaded?
Hello. I will try to be super duper quick. So let's go to next slide, please. Just to recap, what we have in this draft is that not all BMP message types do support TLVs in the original design. So route monitoring and peer down were left out, and with this draft we are trying to add TLV support for those. And contextually we bump the version to version 4 for backward compatibility. Next slide, please. Fifth version of the draft was submitted earlier today. Very sorry for the last minute thing, but there is totally no drama going on. So the previous version expired. We refreshed just we bumped the version. We incorporated a very useful comment from Jeff, where he was saying that we have generic TLVs and indexed TLVs, and the indexed TLVs apply only to route monitoring messages, right? So thanks, Jeff, for the input. It was very valuable. Also, we had one of our co-authors, Hank Smith, that he asked to be removed since he has a new employer, and so he didn't want to be associated with this draft anymore. Next slide, please. So a recap of what I just said, like we have generic and indexed TLVs, right? So 1 and 2. So you can clearly see the difference between the two. It's super duper simple. So the first is just the TLV, and then the second is a TLV where sandwiched between length and value, you have these 2 octets of an index, right? The purpose is to have these index TLVs as part of the route monitoring messages so that you can address one specific NLRI, which is included in a BGP update message carried by the route monitoring message. Next and last slide, please. So we are doing a little bit of preparations for next version. So if you read the current text of the version 5, you see that the route monitoring message can contain both generic and indexed TLVs, right? Why is that? The reason is very valid. It's because you want to address something for the whole BGP update message, like this BGP update message is packed with the add path. Okay, and maybe you want to address some characteristic of the specific NLRI. Reasons for that may appear in other drafts that use TLVs, like the BMP path marking. Okay, so what is the problem is that auto parsing is broken by allowing both generic and indexed TLVs, because then a parser would need a specific knowledge and know which TLVs are generic and which one are indexed, okay? So let's try to fix it. So 2 options proposed that we could think of. So we only allow indexed TLVs, and we give semantic meaning to index 0, where we say that the index 0 applies to the whole BGP message. And of course, if we don't like the index 0, it could be, all ones, for example, maybe because there are already implementations counting from 0. But let's say we give semantic value to one specific index, and we say that applies to the whole BGP message, and then all the others means that it applies to a specific NLRI. And the other would be to go another way, which is, we either have a specific flag space or something like that, carved into the TLV type field. But the thing is that, if you go with flags, let's remember we have already another draft that wants to add a flag, the E-bit flag, the enterprise bit flag. And so having flags carved out of a TLV type, it gets very clumsy how you pack stuff. You get very variable length. It could be a little bit messy. So boxed in red, we have what we think is the best solution. It's maybe not the best design, but it's simple. It achieves what we want, and I don't really see drawbacks with that, right? So it's definitely not the most beautiful design, but it's functional. So with that, I'm finished, and I don't know if there is any comments or if we have time for any comments.
Probably can squeeze in 2 questions if they're quick. Going once.
How are you on running code with BMP TLV, Paolo and team?
So we have already running code with Huawei devices exporting TLVs and PMSCCT receiving them. We have also a prototype made with SCAPI, which is something to craft packets, let's say. And that's it. And that's working up to version 5. And of course, with version 6, if we go to only indexed TLVs, then this has to be changed.
Okay. Any questions for Paolo? Going once? Going twice? Thank you so much for your update, Paolo.
Thank you.
With that, I think we have arrived at the end of our Grow session. We're 7 minutes over. Thank you all for attending this meeting, and we'll see you in a few months at IETF 112. Chris, is there anything you want to add to this?
Not at all.
All right. Thank you, everybody. Have a good night.